We're going to try out one more example of verification of a trigonometric identity. For this one, we have the product of tangent of alpha plus tangent of beta and 1 minus the cotangent of alpha times the cotangent of beta, plus the product of cotangent of alpha plus cotangent of beta times 1 minus tangent alpha tangent beta. That's all equal to 0. First thing we need to do is start with the more complicated side. And if you're thinking anything but left-hand side, you're crazy. Yes, I'm going to start with 0 and end with all of this. No, you're not. You will not do that. So we're going to have to squeeze this in here. This is a bit of a long statement. Now, something that I emphasize to all of my trigonometric students, especially when they're starting out, is that when you list a trigonometric function, it is 100% necessary to list the corresponding angle. This is due to the fact that occasionally you'll encounter some problems where you have multiple different angles. This is one such problem. And we'll include our justification way over here. Though we might need some wider paper for this, my goodness. So first thing I'm going to do right out of the gate is when I have two things added and two things subtracted and those two things are being multiplied together, what I tend to do with that is FOIL. So tangent of alpha times 1. Then outer, that'll be minus tangent of alpha times cotangent of alpha times cotangent of beta. I will be tangent of alpha times 1. And then last will be minus tangent of beta. Wait, no, see, I did it right there. First, outer, inner. Yeah. Remember that thing that I said was super important and then immediately screwed up? Yeah, don't be like me. Be the responsible student that's copying down the correct angle. So that's the first FOIL that we get. Over here, I'm going to do the second FOIL. So cotangent of alpha times 1. Cotangent of alpha times negative tangent of alpha tangent of beta. Cotangent of alpha times tangent of alpha times tangent of beta. Then inner, we've got cotangent of beta times 1. Then minus cotangent of beta times tangent of alpha times the tangent of beta. Normally, I would say that we're justifying this with algebra, but I need to throw down a 4-letter F word right there just based off of how much writing I had to do for this step. Now at this point, I'm going to point out that we do have tangents and cotangents are relatable very nicely through the use of reciprocal identities. So as an aside, the reminder is that the cotangent of theta is equal to 1 over the tangent of theta. So a variation of this is that if you have the cotangent of an angle times the tangent of the same angle, you can replace that with a 1. That's what I'm going to do at the next step and refer to it as a reciprocal identity. Here we see that not taking place. That's just tangent of alpha. In the next expression, however, we have tangent of alpha times cotangent of alpha. That will be 1. So the only thing left will be minus cotangent of beta. We'll keep the next step, tangent of beta. And at the next step, I see a tangent of beta times cotangent of beta. Those will cancel each other out. So we'll have minus cotangent alpha. Working through the next 4 terms, cotangent of alpha stays cotangent of alpha. Cotangent of alpha times tangent of alpha, those will cancel each other out by using our reciprocal identity. So this will be minus, those cancel, we're left with tangent of beta. The next term is just by itself, so we'll keep that. And the last term we have cotangent of beta times tangent of beta, those will cancel each other out. And we'll be left with minus tangent of alpha. To justify that step, that was through the use of the reciprocal identities. Next thing to point out, we have a lot of tangents and cotangents and alphas and betas and whatnot, but I noticed that we have a tangent of alpha minus tangent of alpha. Those will cancel. We have a minus cotangent of beta plus cotangent of beta. Those will cancel. We have a plus tangent of beta. We have a minus tangent of beta. Those will cancel. And finally, we have the, you know what? I have all of these different colors over here. I could be using different colors. Then we have the cotangent of alpha, minus cotangent of alpha and plus cotangent of alpha. And we see that everything winds up canceling out through simply the use of algebra. So yeah, this one seemed really scary when we started, but everything turned out fine after just using the reciprocal identities and a lot of algebra.